glazing rundown here, just so that you're up on understanding what glazing does to a building. First thing to note with glass is a very interesting ratio. If you look at these old buildings out there, if you found any of them with their single glazing from 125 years ago, and you looked at it per square metre, the ratio of cost in the Victorian period to build a square metre of glass versus a square metre of wall is about 6 times more expensive. What's also interesting is that the wall is about 6 times higher performing than the glass per square metre. Now that's a very interesting ratio, because if you fast forward to passive house and you take a passive house window and a passive house wall, they're the same ratio. It's 6 times more expensive and 6 times worse performing. This should be highlighting to you how important it is to specify good quality glazing, but it should also be highlighting to you, and this is, bearing in mind, one of the 3 companies I manage is a window and doors company, and I'm the only company you'll find with windows and doors saying, buy less windows. This fad of covering huge quantities of your wall in glass causes some major disruption issues. We are, in the whole world, the worst architecturally designed crisis ready to come in terms of overheating. That is being discussed widely on international architectural circles. You will find yourself in very uncomfortable situation very soon, and this is really easy to understand. How many of you have been approached by a client? I've just bought a new house, I want a new kitchen, I'm going to put an extension out the back. Oh yeah, I really like light, I want it as glazed as possible, roof, walls, everything, glass. So I'm going to put it all in there, and I'm then going to knock the walls out that are inside my house, so I've got the open plan living space. What this actually means is that during the night it's much cooler, and it doesn't just ruin the one space, the new space, it ruins the rest of the house because it's all connected. And then during the hotter periods, the exact vice versa occurs. And you can literally go from being too hot to too cold within the 24-hour period. This is very common. So to consider glass as being something that you can freely put anywhere is definitely a mistake. And consideration of a 3-step process can completely revolutionize the way in which you specify glass. The first is called glazing minimization. If you think about it, if it's 6 times more expensive and 6 times worse performing, and I'm doing the 6 times worse performing thing, comparing it against heat loss, it also has the downside of overheating. So there's 3 things that are negative against it. If you can have less of it, it will save your client money and make them more comfortable. What you need to balance, obviously everything's a balancing act, is the design element, so that you're still maximizing the amount of light that's coming into spaces. And this is really easily achievable with interior design and in terms of aspect and orientation. There are lots of clever modeling software packages available today to enable you to kind of map the sun and understand how light will penetrate the building and how you can use it. So for instance, the flooring that you've got in here, this is a timber flooring. I love wood, it's very sustainable as a product. It's about 2 megajoules per kilogram versus if it was steel, that's 56 megajoules per kilogram. Aluminium is 256 megajoules per kilogram. So just think, whatever product you're specifying, it has a kind of embodied carbon that goes into making it. So wood is very, very low, but also the downside of it is that it can be picking up a lot of that light. It's very absorbent of light. So what we've done is applied a natural product, a hard wax, called Osmo Raw, and that essentially enables us to keep this kind of chalky finish, almost like a freshly sanded finish. The beauty of that is it gives you all the hard wearing elements, which means you can use a softer floorboard and still get your sort of 10 years worth of life out of it. But more importantly, from my perspective, I can have less windows and still use more of that light as it comes in. It's not being sucked into the floor and other wooden elements. So it really ties into a kind of a wider understanding. Everything with sustainability is about holistic design. So minimization, simplification. That room through there, the original front master bedroom, had 9 windows in it, 5 of which originally were opening. Think about this. If you look at the detail here, out of the 106 details that I was mentioning downstairs associated with the construction of this building, a lot of them focused on windows and doors, as you can imagine. You've got different details for your kind of lintels and jambs, etc. And what we were designing here was something that gave us no thermal bridging, what we call a negligible psi value. And we designed that by integrating that into the wall. So they're essentially one seamless connected unit. The other advantage is that you can make the frames disappear. You can really kind of get maximum glazing apertures there. And if you look at the ones at the front, every time there's an opening unit, think about it. You've got to have clear frame that goes back around. And when you're talking about high performance glass, that is basically quite fat. So you start to lose that area, but it also costs twice as much. You've got 2 frames, not 1. You've also got even more than twice on that basis, on the basis of ironmongery, the hinges, the handles. And now you've also got thermal pathways, gaps in your framework, which you need to work very hard to make sure that they maintain an aligned setting so that you don't get drafts coming through them. On that, most of you will do comparative studies when you're specifying windows. You might look at the U value of a window and the cost of a window. Those are the typical 2 big drivers. The problem with U values is it's only one form of heat loss, conduction. It is not looking at convection, direct air loss. If it's warm in here, it warms up your wall. If your wall is warm, it warms up outside. It's an indirect form of heat loss. How do you slow that down? You slap insulation on it, inside, outside, in the middle. And you can slow that process down. But if there's a gap in that wall, the air can go straight through it or straight into your building from the outside. That kind of heat loss is known as convection. It's actually more powerful. It represents 50% of the overall heat loss from a building, whereas conduction is only 40%. I say only. Obviously, they're almost equally weighted, so you should be dealing with both forms of heat loss at any given specification point. What you shouldn't be doing is wasting your time with foiled layers. With anything around radiation, it's less than 10% of your problem, it's expensive, and most importantly, it's non-breathable. So you can cause some major issues with all of that.